We have this question right here. It's asking evaluate the determinant of the matrix, and we have this that first question, and the second question is asking what does this tell you about the linear dependence or independence of the column of the matrix. So first of all, let's see how we can find the determinants of the matrix. So in this case, whenever you see something like that, if it's 3 by 3, it's easy to find the determinant, but if it's 4 by 4, it's better to bring this into upper triangular form and then multiply all the uh, diagonals of this matrix. So first of all, what I'm gonna do is I write uh, the original form right here, 0600. It's going to be 2806 right here, then 8735 right here, then 1403 right. Then after that, what I'm going to do is I'm going to, if you see this question, the first one has 06000. Like if you like in this time we have to think, if you see that if I bring this one into the bottom, it will make everything in the bottom 0, and it will make our life more easier because it will then we need less steps to solve this problem. So let's do this. So first of all, I'm transferring the first equation to the, so this is, let's say this is a determinant A. So if this is a determinant A, to find, I'm just transferring the fourth one with the first one. So it's going to be 1403 and 2806, then 8735, then we have uh, this one I brought it to bottom. It's going to be 0600. Now what's going to happen is, according to the determinant rule, when you swap once, it will become negative. Like the sign changes every time you swap. So if you swap again, it will become positive. That's how it works. So in this case, I swapped once, so therefore it's going to be negative determinant A. Then what I'm going to do is I have to bring this into upper triangular. I have to make this whatever the numbers below the diagonal should be 0, right? So uh, let's eliminate the first two variables. So if I do that, to do that, what I have to do is, let's see what I can do. Determinant of A, then first one we don't have to eliminate because it's in the diagonal. So 1403. Second we need to eliminate, so in order to do that, I multiply the first equation by negative 2 r1 plus r2. So if I do that, you see it's this is the multiplication of this one. So when you multiply this one negative 2, everything becomes 0. You can notice that it's going to be 0 0 0 0. And the third one, I can multiply this one by negative, first equation by negative 8 and add it. So if I add that one, I will get 0, negative 25, then 3 minus 90. So this is going to be my third row, and then we have this fourth row. It's going to be remain same, 0 6 0 0. Now what you can see is, if you see, this one is better to be in the bottom than this one because this is all 0. That's what we want in the bottom. So if you swap this one with the bottom, it will make this much more easier. So let's swap it. So if I swap again, this will become positive now. So it's going to be 1403 0600. Then we have 0 minus 25, 3 minus 19. Then we have 0 0 0 0. So this is going to be my value. Then what I can do is, I had to since we have eliminated all the line along here, now you see diagonal is this one, right? This one. So if you see, I have to eliminate this second variable, this is the only thing remaining. So to do that, if you see, I can't use first equation because we have three variables and it will mess everything up. But if you see, second equation has only one variable that is in the second column. So I can use this one to eliminate this one, but this is 6. I have to make it into simplest form. To do that, I can simply divide this one by 6. So let's divide. So what's going to happen is, if I divide by 6, I have to take that form to outside. So according to the determinant rule, whatever you multiply or divide, you have to bring it outside. So for example, this one is going to be then 1 by 6 determinant A. So it's going to be now 1403 0100, then 0 minus 25, 3 minus 19, 0 0 0 0. So this is the form we have right here. Then what I can do is I can simply I have to eliminate the 25. I can multiply the second equation by 25 and add it with the third equation. So that's what I'm gonna do. So it's gonna be 1403, then multiply the second equation by, okay, second equation remains the same, 0 1 0 0. Then I multiply the second equation by 25, r2 by 25, and r3. It's gonna be now 0. See, this one is 25 0. Then this is going to be 3. This is going to be minus 19, and the bottom is going to be 0 0 0. So from now you can try to solve it. We have 1 1 3 0 right here, 1 1 3 0. So if I find the determinant of 1 over 6 this is 1 over 6 determinant A. So 1 over 6 determinant A is equal to 1 times 1 times 3 times 0. So this is going to be 0. Therefore, if I flip this one, if I find determinant A is going to be 0. So this is the answer for the first question. Evaluate the determinant. We have found it's 0. The second question is asking, what does this tell you about the linear independence or independence of the column of the matrix? So in order to, if you want an equation to be linearly independent, the rule is the pivot should be equal to the vectors. Pivot should be equal to the vectors. Number of pivots should be equal to number of vectors. So in this case, we have 4 vectors right here. Every line is a vector. So 1 vector, 2 vector, 3 vector, 4 vectors. But if you see the fourth column, we eliminated because this is like an addition of 2 columns, or so multiple, like it belongs to one of these. It means we only have three pivots right here, because 3 or less than the, like if you solve it, like we definitely know it's not equal, like it never going to be equal to 4, because we also already eliminated one. Therefore this is not equal to number of pivots is not equal to number of vectors. Therefore this is not linearly independent, and therefore it's linearly dependent. So this is the final answer for this question. I hope you guys like this video. See you next time.